All right, so we are on 6B, day 2, and again, we are interpreting relationships between quantities. Exciting stuff. All right, learning goals for this lesson. I can identify a graph that correctly models a real-world situation, and I can create a graph that correctly models a situation when given information. All right, so again, things to remember. Common theme so far for A and B is that use your common sense. These problems are not as hard as you think they might be. Okay, so a lot of it is just common sense. So for example, diagram shows a portion of a bike trail. We need to circle the graph that is a reasonable representation for biker A. So here we have biker A way up here. Okay, and we want to explain our reasoning. So which graph would it be? Okay, we're looking at speed. So this is their speed. So if it's flat, remember their constant speed. If it's going down, they're slowing down. If it's going up, then they're speeding up. Okay, so and then that's over the course of time. So of course, so we've got biker A, and he's going to go down this hill. So we're going to pick this one. Okay, not because it looks like a hill, but because if you look at the graph, biker A started at a constant speed, which we have right in here. Okay. And then he went down the hill, so his speed increased. So even though he's going down the hill up here, he's going to go faster. His speed's going to go faster. So since this is speed, it goes up. And then as he got to the bottom, his speed decreases because the ground levels out. So that's his speed decreasing. And then eventually he maintains that same steady pace the entire time. So that's the reason for that. Don't go by the picture, okay? Go by the graph and what makes sense. Second example. So we have a graph at the right, well actually below, that shows the vertical distance traveled as person A walks up the mountain. And so this person's walking up. How you doing? And this person B, is flying up the mountain in a helicopter, so they're kind of cheating. I'm just trying a quick helicopter here. Not going to be the best one in the world, but you get the idea. All right. So they're flying up. This is person B. This is person A. And we want to draw a line that could represent the vertical distance traveled as person C runs up the mountain. All right, so we've got person A there walking. Person B is flying in a helicopter. Now notice they're both going the same distance. They stop at the same place. The varying factor is how long it takes them, because this is time down here. So if you're running up, is it going to be as quick as a helicopter? No. Is it going to be faster than walking? Yes. So person C, our runner, would be right in between the two. Not necessarily exactly in between, but as long as it's in between the two, then I'm okay with that. And again, it goes the same distance, it just does it in a quicker time. Like if we drew a line down, this would be one time, this would be another time, and then this would be another time. So this would be the time for the helicopter, for the runner, and for the walker. So your reasoning would be person C is running, so they will be faster than person A, the walker, but slower than person B, the helicopter. So we got our points for drawing in our line because it asked you to do that. See, it says draw a line, so we did that. And then we also explained our reasoning. Okay, so make sure that when test time comes, that we're doing everything that we're being asked to do. All right, so we are almost halfway through this unit already. Exciting stuff. But if you have any questions on this, again, no calculations to do yet, no computations, but still room for confusion. So if there's anything that you're not sure about, please come see me. Thank you, guys. You have a